FK202 crack width detector adopts wireless connection mode, and is widely used in quantitative detection of crack width of bridges, tunnels, building main bodies, concrete pavement, metal surfaces, etc. The instrument consists of a tablet computer and a microscopic probe. During measurement, the microscopic probe will collect the crack image in real time and transmit it to the tablet computer through wireless mode. The tablet computer will display the received crack image in real time and automatically capture the crack and display the crack width value through the built-in program. 1. Technical indicators. 1. Test range, 0 to 10 mm. 2. Test accuracy, plus or minus 0.01 mm. 3. Storage capacity, 64 GB, and supports the maximum 512 GB of extended memory. 4. Power supply, rechargeable lithium battery. 2. Startup precautions. First of all, long press the power button on the microscopic probe to turn it on. The indicator is in the stroboscopic state. It means that the microscopic probe is in sufficient power and needs to be charged first. Note, when the microscopic probe battery is too low, it can't be turned on. After the microscopic probe is turned on, turn on the tablet, then turn on Wi-Fi, Bluetooth, and GPS. 3. Crack width detector interface. Open the software of Langrye's crack width detector, and the main interface displays crack width detection, data management, parameter setting, and instrument calibration. Click the crack width detection to enter the crack width detection interface, which is mainly divided into 3 areas. 1. Parameter area. Click the white arrow on the left side of the screen to pop up the parameter area. The main information includes delegate number, project name, experiment number, test item, object name, etc. The delegate number is required. 2. Display area. This area displays the crack width in real time, and displays the object number, crack number and measure point number at the top of the screen. 3. Operation area. This area is located at the bottom of the screen, and is composed of 5 functions, namely, new object, new cracks, black white, OK, and back. When continuous crack width detection is performed, the system defaults to the measurement point number +1. 4. Crack width detection. First, the probe is placed vertically on the surface of the component to be measured, so that the center line of the probe is pressed near the center of the measured crack, so that the crack center is located in the middle of the screen. After the picture is stable, click the photo button on the probe to lock the picture. At this time, if you need to manually determine the crack boundary, click the arrow, and drag the blue boundary arrow to select the boundary you want to measure. Then click Save to complete the crack width measurement of the measuring point. If you need to detect the next component or crack, you can click New Object or New Cracks on the screen. Click Black-White. You can switch the display area to the state of the black and white picture display. Click OK, and then click Save in this state. Then the saved picture is black and white picture effect. Click Original Drawing to return to the original picture screen. Click OK, or press the photo button on the probe to lock the screen in the display area. The screen is static. Click back to return to the main interface. 5. Data management. In the main interface, click Data Management to enter the Data Management interface. The interface is divided into a data list area and a data operation area. The left side of the data list area is the delegate number. The selected delegate number is dark blue. The right side shows the saved component data, including project name, date, experiment number, object parts, average width, and so on. Click one component to view all the crack data saved under this component. Click on the data of any crack to view the measurement point data under the crack. Click on the picture to enlarge the view. The data operation area is located on the far right side of the screen, with 6 function keys. Among them, the exported data can be inserted into the tablet with a USB drive. Click Export USB drive, and export the selected component data to the USB drive. Note, only the component data under one delegate number can be exported to the USB drive at a time, and the USB drive only stores the last exported data. Then plug the USB drive into the computer. Open the online system management software on the computer. Click Crack Width Detector. Click Import from USB drive, and you can import the data into the software. You can also use the data cable to connect the tablet to the computer. Select the component on the tablet, click Export PC, and then click Import from Device, and the computer management software for Crack Width Detector. You can also import the data into the software. And then you can process the data and generate a test report. Six, Parameter Setting. Click Parameter Setting on the main interface to enter the Parameter Setting interface. The interface consists of three parts, namely, Threshold Adjustment, Paired Probe, and About. Click Threshold Adjustment to set the threshold to vague, standard, or sharp. The default threshold is standard. By setting the threshold value, the boundary standard can be adjusted when the system automatically determines the crack width. Click Paired Probe, and the system will automatically search the probe number, so that the tablet and the probe can be matched. Click Probe Number, and the system will automatically complete the pairing. Note, by pairing and unpairing, the tablet can be paired with different probes to work. After replacing a different probe, the instrument should be recalibrated. Click About to view the product model, software version and upgrade probe firmware. Software and probe firmware upgrades require networking first. 7. Instrument calibration. When the observed value of the crack width is in doubt, or when a different probe is replaced, the instrument needs to be calibrated. Instrument calibration should be carried out with a calibration plate. In the main interface, click Calibration, and enter the password 8888 to enter the instrument calibration interface. In the upper left of this interface, there are tips for calibration steps, such as placing a 0.04 mm width crack. You need to place the probe on the 0.04 mm crack calibration line on the calibration plate. When the probe captures the crack, the screen will display the blue cross cursor and the red crack center line. Move the probe to make the cursor coincide with the center line. When the picture is stable, click OK to lock the picture. Then click Save to complete the calibration of the crack width. Then proceed to the next width calibration. Users can calibrate according to their needs. If they choose to skip the calibration of the current width, the system will continue to use the last calibration result of the width. When you need to recalibrate the previous width, you can choose Retreat to calibrate again. After the calibration is completed, the system will prompt and automatically save the calibration result. Note, if you click back before the system prompts the end of calibration, the system won't save the calibration results of any width of this calibration.